Today we're delving into the life and potential death of Betelgeuse, a star that could soon light up our skies in a spectacular supernova. A supernova is no ordinary event. This explosive end to a star's life cycle releases an unimaginable amount of energy, outshining entire galaxies and sending shockwaves rippling through the universe. The scale and impact of such an event is hard to comprehend, but one thing's for sure. When it happens, it's a sight to behold. So, what if this cosmic spectacle was to occur right in our cosmic backyard? Strap in, stargazers, as we embark on a journey through the cosmos. Now, let's explore the fascinating journey of a star's life and its ultimate explosive end. A star's life is a cosmic saga, beginning in a nebula and ending in a spectacular explosion, or a quiet fade-out. Picture this journey as an epic tale of transformation, taking place over billions of years in the vast theater of the universe. It all starts in a nebula, a vast cloud of gas and dust. This is a star's cradle where it spends the early days of its life. The nebula's gas and dust particles are drawn together by gravity. As they become denser and hotter, a protostar is formed. This is the first stage of a star's life cycle. The protostar continues to grow, collecting more and more matter from the nebula. As the pressure and temperature increase, nuclear fusion begins. Hydrogen atoms collide and fuse to form helium, releasing a tremendous amount of energy. This is the birth of a star, and it marks the beginning of the main sequence stage. The main sequence stage is the longest phase in a star's life, often lasting several billion years. During this time, the star shines brightly, its light fueled by the continuous process of nuclear fusion. This is the stage our sun is currently in, a typical main sequence star converting hydrogen into helium in its core. But what happens when the star exhausts its hydrogen fuel? The core contracts, and the outer layers expand. The star swells and cools, becoming a red giant. The star now begins to burn helium into heavier elements such as carbon and oxygen. This phase marks the twilight years of a star's life and can last from a few 100,000 to a few million years. The fate of a star after the red giant phase depends on its mass. Stars with a mass similar to our sun will shed their outer layers, leaving behind a white dwarf, a hot, dense core. Over time, the white dwarf cools and fades into a black dwarf, a quiet end to the star's long journey. Stars with a mass greater than about 8 times that of the sun have a more dramatic fate. The helium in their core fuses into heavier elements all the way up to iron. The core collapses under its own gravity, triggering a violent explosion known as a supernova. What remains after the explosion is either a neutron star or, in the case of the most massive stars, a black hole.